In the previous video, you learned about the Pythagorean theorem, and now we're going to look at the Pythagorean triples. Pythagorean triples are a set of three integers that satisfy the Pythagorean theorem. And here we have 3, 4, 5. This is actually the most basic of Pythagorean triples, and this has a special name. It's called a primitive Pythagorean triple. Primitive because we can't take these numbers down any farther. They're basically at their prime numbers. So that's why it's a primitive. This isn't the only Pythagorean triple, and it's certainly not the only primitive Pythagorean triple. 5, 12, 13 is another very common primitive Pythagorean triple. And 8, 15, 17 is yet another very common Pythagorean triple. There are other ones beyond this. You can look them up on the internet if you really have a burning desire to find out what they are. But 3, 4, 5, very common. 5, 12, 13, fairly common too. 8, 15, 17. Those are ones that pop up more so than others. Now, going back to the definition, you'll see a set of three integers. So a Pythagorean triple, even if it's not a primitive Pythagorean triple, they're going to be all integers. That means they're going to be basically all whole numbers. We're not going to have a negative number here. So down here we have a Pythagorean triple. We can find out what the primitive Pythagorean triple is by determining whether they all have a common factor, and they do have a common factor, and that's 5. So if we wanted to determine what the primitive Pythagorean triple would be, you divide by 5, and for this one it would be 3, 4, 5. You don't necessarily need to find the primitive Pythagorean triple for all your answers. You're basically just looking for the Pythagorean triples in general. If you have a decimal point, that's not a Pythagorean triple. It's got to be some set of a whole number. So a few things to remember. There's essentially 3 steps for the Pythagorean theorem. First, you have to square the numbers you have. Then you add or subtract based on what side you're looking for. And finally, you take the square root and you round it to the nearest tenth. And the Pythagorean theorem only works for right triangles. It will not work for obtuse triangles or acute triangles, only for rights.